Let's say I have the following function, where I have an outer function set mean type, and then I have an inner function mean, and then the outer function returns the inner function mean. And the idea is that the inner function calculates the mean, but the outer function will specify what mean type do you want to calculate. Do you want to calculate arithmetic, geometric, or the harmonic mean? So basically, the outer function will wrap the inner function, and it will allow the user to modify how you want the inner function to be called. So let me run this. I can create two different type of functions based on the type I specify. So for example, I can create get arithmetic mean set mean type arithmetic, and similarly get geometric mean set mean type geometric. So basically, because of this function wrapping, I'm able to create two different type of mean functions. Now if I run both of these functions, you can see they calculate mean differently. Another great use case of function wrapping is, say, when you want to add more functionality on top of an existing function. For example, we can annotate an existing function. We can write def annotate, then input our function func. Then our inner function is def annotated, and obviously it will have its arguments. And then we are going to annotate the inputs and outputs. So we can write print fstring, and to get the func name, I can write func dot double underscore name is taking inputs the args. To annotate the output, I can write print output was, then the outputs calculated, and then I will simply return annotated. Cool. Now if I have a sum function, I can annotate this function like this. And now if I call the annotated function, it will return the results annotated. As we see, sum is taking inputs 1, 3, output was 4. Previously, we left off with this function example. Now this particular form of function wrapping, where you have an outer function that takes a function as an input, and then you have an inner function which adds functionality to that function you passed, and then returns that modified function, is what's known as a decorator. Because you can think of adding functionality as quote-unquote decorating. And since this process of decorating functions is so common in Python and in programming in general, Python actually has its own special syntax for decorators. If we revisit our sum function, the original way to decorate it was to simply do sum equals annotate sum. But did you know that you could have achieved the same effect by simply doing at annotate? Now, if we run sum, we see that it is annotated by using the decorator syntax. Now, at first glance, this syntax may not seem handy because the original way, it wasn't that much code. All we did was this. But the difference between doing it like this and doing it like this is this, you're changing the function at function call by calling it, but this, you're modifying the function at definition. And this is especially useful when, for example, say you're defining a bunch of functions. If your intention is to define them with the same added functionality, you want to create your decorator once, and each time you create the functions or define those functions, then you just have your decorator syntax. For example, if we had multiple functions, sum, subtract, multiply, divide, and power, and we wanted to annotate them, instead of defining this decorator each time, we just define it once, and then we decorate each function like this, at annotate. Now, if we run these functions, we see that all of them are decorated. Now, for a moment, let's get back to our decorator. Let's take all this out. Okay. We can even make our decorator itself sort of customizable by adding another layer. For example, let's say we wanted to give the user the option to make the annotations all caps or not. Then we can add another layer like this. Define annotate all caps equals false by default. Okay? And then what I'll do is I will indent this, and now I will call this annotate func. And because I'm adding another layer, similarly I would have to return annotated func. Now what I'll do inside is I'll write an if statement for if it's all caps is true, it'll make these uppercase, and if it's false, I'll just leave it as is. So what I can do is if all caps equals true, then indent this, else put it right here. But I can use the .upper method on an f string to make them all uppercase. Okay? So now, if I take just two of the previously decorated functions I defined, sum and subtract, what I can now do is I can customize these decorators. Let's say I want to make this function to be all caps and this function to not be all caps. I can say all caps true, and then all caps false. By the way, since all caps is false, I won't even have to specify this. So actually, I can even just take it right out. So now, for example, if I do sum 1, 2, and if I do subtract 10, 5, you can see that the first one is all uppercase, but the second one was not uppercase. Further, let's say I had 3 decorators, decorator A, decorator B, and decorator C. I can even chain decorators on top of each other. Let's bring back our sum function. So sum as is, if I do 1, 2, will just return the result. But if I put add decorator A, what will I get? Now if I run it, I see it has decorated the sum function with this print statement. But now if I put add decorator B, now it has decorated that on top of with this print statement. And further, I can even chain decorator C. And you get the idea. Now the order is important. The way I order this is exactly how it's decorating it. If I were to, let's say, put C here and B here, you can see how the order changes. Now, if you're lost with all this decorator madness, just remember that if I take this, writing this is the same as writing this. You had decorator B first, and then decorator C, and then lastly you had decorator A. And now if I were to, sorry, this is supposed to be sum. And now if I did sum, the same one, you see I got the same exact result. Chaining a decorator like this, bottom to top, is like calling functions in cascade, first to last. Further, we can both customize and chain decorators. For example, on top of annotating, let's say we want to give the user the ability to repeat the function call as many times as possible. So, what we could do is we could define another decorator. So def repeat func, and then we can say def repeated, then the arguments, then even the keyword arguments of that function, and then for underscore in range n. Now I haven't specified n yet, but I will get to that in a minute. Basically that is user specifiable. Then I'll write print for new line so it doesn't get too cluttered, and then I will call the function func args and then keyword args. And now I will return repeated So this is the repeat decorator so far. Obviously, we want this to be customizable so the user can specify however many times they want to repeat the function call. So I can add another layer, def repeat n, and now I will indent all of this, and then at the end I will return repeat. And since I have two functions called repeat, obviously I'll have to give this a different name. Repeat func, and then repeat func. Now you may be wondering why I use an underscore. Now typically in a for loop, when you don't care about getting the item, you just care about running the loop for X amount of time, you can use the underscore as like a placeholder. Okay? Now what I'll do, I'll copy and paste my previous customizable annotate function. And I'll bring back the two annotated functions that I defined, sum and subtract, where the first one, I wanted it to be all caps, and the second one, I didn't. I can add a second layer on top of these. Let's say I want to repeat sum 3 times. I can say repeat 3. And if I want to repeat subtract 10 times, I can say repeat 10. Okay? Now if I call sum 3, 2, I repeated that function call 3 times and it is in all caps. And if I do subtract 36, I repeated this function call 10 times and it's annotated without being caps. So this is an example of how you can chain decorators and make them customizable, meaning the user can specify arguments to them, as we see here.